Another quick breakdown of the latest and or greatest pocasa features. That's to be expected. There we go. That up over here, and I'm also pulling up I got my oscope hooked up through USB. I gotta get that running. Cooking. Hurry up. There we go. And just to make sure it's working. Okay, it's working. Let's run that 3 divisions down. Now let's make it 2. In addition to all the other stuff I've done before. Okay, well that didn't work. Looks like I gotta reset it. There it goes. Yeah, here's a little thing here. If I collect all the random points, it's going to spit out. I think it spits out 1,000 of them, maybe 10,000. I don't remember, but it's counting up, and it's filling the screen up with garbage. Let that finish cooking. I got another button here, clean up XY data points. What that does is it looks at every data point on there, and if that data point doesn't have a neighbor, it clears it. Therefore, you can get some extraneous crap out of there. You know, say I got a straight line going across here, but I got onesies, twosies float all around here. Well, I click this one, and it'll get rid of the onesies, twosies. Just make a thicker line. Doesn't do anything statistical or anything like that. Just if the dot's got a neighbor, it stays on there. If the dot doesn't have a neighbor in any direction, it clears it out. It's about halfway done. Let it cook here. Yeah, a little button here just to tell you how long the circuit board's been up and running. Got phase for each of the frequency 0 and the frequency 1 channel. You can set a phase offset for your sine waves or your triangles or whatever you want. So you can do frequency shift keying output in addition to or phase shift keying output in addition to a frequency shift keying output here. These 1 through 10K buttons. Normally, if I click here once, it'll go up to 61. If I had the 10 selected, it'd go up to 70, and 10K selected, it'd go up to 10,060, etc., etc. Okay, so now we look at the screen, and it's got all this garbage on there, and I'm going to hit this clean up XY data points, and you can see it gets rid of the extraneous ones. And if I hit it again, the picture's going to look exactly the same because each one of these dots that are on there, there's 2 or more dots with each dot. So, and I can clear this. You can redraw them. They're still on there because they're stored in an array, a big old array. Over here is the oscope output. I've got my frequency generator, or the frequency output is hooked up to this one here. Whichever frequency register I select, whichever value, whichever mode, and the pulse generator, which is these down here, is hooked up to this one, so I can watch that go. So now I'm going to go ahead and turn on the frequency, and it'll start showing up here. Let me dial back the... Okay, that's 5.453824834 hertz. So I'm going to go ahead and dial that up a ways. Now we're at 900 hertz. There we go. I'm going to slide this over here. In fact, I'm going to put this on the left side of the screen. Because right now we're not dealing with anything otherwise. And this is a direct output over USB. So I got 899.53 or 52 here, and it's registering 899.55. So I'm going to go up. Well, that's going to work great. I see that. Every time I click that, it's going to unclick itself. Well, take my word for it. This will show what I tell you it'll show, because it'll be on the other. It'll be on my other monitor, but it'll be there. 899. So let's say I back this down by half. Should go down to 450. 452.48 is what it says there, and my oscope software says 452.47, give or take. So anyways, I select the triangle. There's my nice triangle wave. Select my sine wave. Takes a little while for this thing to update though. Here, let's do that. Make it a little bit easier to see here. Here's my triangle. There's my sine. Here's your sine. Some square wave going on here. I got to dial back the offset. Divided by 2. And the oscope screen is updating almost immediately. It's just what I'm pulling in over USB takes a while to come back in, so just the way it is. Dial this back up a bit so I can see it. There it is. Okay, let's go to say 1 megahertz. There's 1,500,000 kilohertz, 61 hertz. And there it is. My division time is 2 microseconds. So let's dial that right back to 1 million hertz. So yeah, okay, 2 microseconds. Oh wait a minute, that's right. It's using this right here, so that's 89.4 kilohertz. So let's dial it up a little bit till I get to 1 megahertz. See if I can get it dead on 1 megahertz. It's getting there, don't worry. I ain't worried, I ain't scared. They're 999, okay, they're 1 megahertz exactly. So let's spread this out a ways. I think that, okay. Center it up. Wait for it. Okay, this is 2 microseconds or 100 nanoseconds per division, so that means 10 divisions is going to be 1 megahertz. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 megahertz or 10 divisions, 100 nanoseconds, 1000 nanoseconds, 1 microsecond, 1 megahertz. Yay. Okay, so enough of that. That's the frequency output. And just for comparison's sake here, I'm going to go ahead and dial this down to say 10,000. And I'll put this at 20,000. I said 20,000. There we go. So this frequency is 894 hertz, and the F2 frequency is twice as much, 1788 hertz. So there's my 10 kilohertz or my 894 hertz, and this one here should have twice as many waves in it. There it does. Switch over to triangle, switch over to sine, switch over that, switch over to triangle. Okay, that all works fine and dandy. Let's go down here to the pulse generator. These here aren't really frequencies yet because I don't have the math quite done, so got that turned on, but I got a 0% duty cycle, so I'm going to turn on 50% duty cycle. And over here in my oscope, I have to change my trigger source over to channel 2. Which is not wanting to change my trigger source over to channel 2, so I'm going to dial this frequency down here. Come on, cut me some slack here, will you? I think I can dial this down far enough to make them sync up. Why is it triggering off of channel 2? Okay, let's try 2000. Should have played with this a bit more before I tried to make a video of it. Eventually the two triggers are going to sync up. Why is that not triggering? There we go, single trigger, channel 2. There we go. Still not syncing up. What the hell? Oh, duh. There. edge trigger. Okay. There we go. See, now I can sync them up. It's triggering off channel 2 right now. And if I look at my scope, I got 67 hertz here, but it's saying that the bottom frequency is 59 hertz. So let me slow that down to 59 hertz. .86 hertz. And the top waveform will just barely crawl across the top. 59.8. Yeah. Now it looks like that's about as good as it's going to get, and that's fine. So, what I got here is I got my output waveform set at 59.9 hertz. My pulse generated frequency, it says 195 there in the bottom, but like I say, that's just a delay number. And what the actual frequency is 59.85 hertz. So it's triggering off the bottom one, but reading both of them. So the top one is a tenth of a hertz off, which means about every 10 seconds that wave is going to complete one cycle across the center line there, because they're 1/10 of a hertz off, and that's fine. 50% duty cycle at the top is exactly the same as the bottom. If I go to 99%, there it is. Let me zoom that out just a bit. There it is. You see it's mostly on, 1% off. Go to 1% duty cycle. Mostly on with a spike, or mostly off with a spike on. I can turn up my duty cycle. And the duty cycle is actually a ratio between this number and this number. So at 194 it would be like 99. 195, this number, PG duty, will be 100%. And at 0 it would be 0%. Basically that frequency number is just a tick count, if you will. There's 195 ticks per wave of the pulse generator. So the longer the higher the number, the longer the ticks, the longer the wave. What else? DS, X1, and X2 are just test buttons I had going on. The phase, we could see the phase, but it's best seen on an analog scope, and if you have a reference waveform. I don't have it set up that way. If you could see the phase working, you'd see maybe something. Maybe I dialed in 180 degrees out of phase. I'd see a reference wave be up at the top here, and my generated wave be at the bottom, meaning they're 180 degrees out of phase. What else we got here? Okay, yeah, there's those other points. I got to draw a grid down here. So anyways, all those buttons work. Change that to my triangle wave. Yay, it works. And that's all I got to say about that.